okay? And you might be thinking, wait a minute, how does that help us? I mean, from here, right, we get this. Notice this gives us a way to calculate the probability of the complement if we know the probability of the event itself. And the other way around. So here I subtracted P of E from both sides. I could have subtracted P of E complement from both sides. So what I'm saying is, if we know the probability of an event, we can get the probability of its complement. And if we know the probability of its complement, we can get the probability of the event itself. We can do that. Now, why would that be? Why do we care? Sometimes getting the probability of one of the event might be easier than getting the probability of its complement. Sometimes one of those is easier to get than the other. I mean, not always, but sometimes it's easier. You know, again, we know the sum has to be 1. So if we know one of those, we know the other. Not sure if we'll see any examples like that, although I'm sure there are in this chapter. There might be some in the next chapter. In fact, here's another example. Okay, now I want this one, I want everyone to try. Take about 3 minutes. So here we have this bag of marbles, 6 red, 2 white, 5 yellow. Again, we can't tell the difference between any of them, besides color. So there are 13 marbles altogether. We're choosing one at random. There are 13 outcomes altogether. Okay, and 6 of them are red, 6 marbles that is. So the probability of choosing a red marble is 6 out of 13. So we get that. For choosing a white marble, it's similar, right? You know, there's 2 white marbles in there. So there's 2 ways the event of choosing a white marble can occur. So that'd be 2 out of 13. Now, for yellow, right? We want the probability of not choosing a yellow. So we have to be careful. That's not so bad. I mean, there's really 2 ways of doing that, right? I mean, for not choosing a yellow marble, we can say, okay, well, what's the probability of choosing a yellow marble? Well, for choosing a yellow marble, right? There are 5 yellow. So that would be 5 out of 13. But we want the probability of not choosing a yellow. So we subtract it from 1. So in other words, we have 1 minus 5 over 13, which is 8 over 13. You could also think of it this way. How many ways can we not choose a yellow marble? How many outcomes? Well, there's 8. You have 6 red, 2 white. Or you choose something besides a yellow marble. That's 8 out of 13. Same thing. Yeah, I mean, I hope I was successful. I'm just trying to show you how you can calculate the probability of an event's complement, you know, by finding the probability of the event. So hopefully I was successful. All right. There's another example I want us to do. This one I did with the class, my other class that is. So I figured I'll do it as well with you guys. Not to say you can't handle it. To that. Here we go. So I know this is kind of a weird one. Let's assume that a test was given, okay? And we're giving it to a group of students. We recorded the grades, and we recorded what color shirt they was wearing. We're summarizing all that below. Okay, I know it's kind of silly, but we're assuming that everyone had a shirt that only had one color on that day. Okay? Now, we want to know what's the probability that a student chosen at random, so it's choosing a student at random, what's the probability that they wore a blue shirt? Okay, well, if we're choosing a student at random, right, there's 29 students with blue shirts. So there's 29 ways this event of choosing a student with a blue shirt can occur. And in total, there are 80 students, 80 possible outcomes altogether. So the probability would be 29 out of 80. For B, let me go back. What about choosing a student at random and the student we chose earned an A on that test? So now we want the probability of student chosen at random earned an A. How many students earned an A? 31. How many students are there altogether? 80. So it would be 31 over 80. There's 31 ways we can choose a student that earned an A. There's 80 students altogether, so 31 out of A. Now, what about students who did not earn a C? Well, there's two ways of doing that, right? What's the probability that a student chosen earned a C? Well, there are 30 students who earned a C, right? So that event of choosing a student who earned a C, there's 30 ways that can occur. There's 80 students altogether. So we would have 30 over 80, but we want the students who did not earn a C. So we would do 1 minus that, which is, as you can see, 1 minus 30, which is 50 over 80. 1 minus 30 over 80. I mean, what you could have done also was, if they didn't earn a C, right? They had to have earned an A or a B. So these students are the ones corresponding to the event that the student did not earn a C. And that's 50 students in here. So that would also be 50 out of 80. Okay. Now, just another way to find it. Just another way to solve the problem. That's all. Okay. Now, are there any questions about that? Remember, I can't see the chat, so. Okay. Well, this is something. This is something else they do in the chapter. It's not quite probability, but it is related to it. We're going to see what's called the odds of an event occurring, the odds in favor of an event occurring, and we'll also see the odds against an event occurring, the odds. Yeah, it's another way really of telling how likely an event will occur. Again, it's related to probability, but it's not exactly the same thing. And what we can do is we can convert between odds and probability. That is something we can do. So first, let's look at this. So this is the odds in favor of an event occurring. Notice here actually that we have a ratio. We have a colon here. The odds is not written as a fraction. I mean, here it's a fraction, but in the end, it's nothing more than just a ratio. It's always going to be a ratio. And we can use probability to calculate it, but it's always going to be written as a ratio. It's the number of ways that event can occur. And the second number here is the number of ways the event cannot occur. I mean, we could calculate using probability. You have the probability of E divided by the probability of not E, or E complement, in other words. But you would write this answer as a ratio. And down here is, I also have this on the next slide, so let me just go here. Well, wait, before I do that, again, this is a ratio. Okay, this is not a fraction. Probability alone can be written as a fraction, but not the odds. Again, it's written as a ratio. Probability is written as a fraction. We also use different words when we say, ratio and probability. That is, when we talk about odds, we say 2 when describing odds, like 1, 2, 5, as I have down here. 1, 2, 5. So there's one way the event can occur, 5 ways the event cannot occur. So we would have 1 to 5. Probability, even though I wasn't saying it before, people usually say the word in. 1, like if we have this as our probability, 1 in 5. So there is terminology with using with odds and probability. Okay. All right, so that's what happens here. So again, with odds, 1 to 5, probability 1 in 5. Now, that's what happens here. That's the odds in favor of. What about the odds against? Well, the odds against are actually pretty easy. It's just a reciprocal. That is, it's just the odds in favor of, but you invert it. You can see that from here. The number of ways the event cannot occur to the number of ways the event can occur. So the odds against an event. And again, you could calculate it, right? As I said, you just invert, take the reciprocal or flip it, in other words. So in this case, you'll have the probability of not E over the probability of E. And really, by what we did before, on top, you would have 1 minus the probability of E. That's the probability of E complement. So that's what happens here. I know odds, like odds against or odds in favor of, that does get used in casinos and gambling institutions. So it's something that people say. I think they also say it with the lottery, like the odds of winning the lottery are, now you know what that means, in favor of winning the lottery. So, all right. So here's an example. Let's find the odds in favor of, or the odds for, rolling a die and getting a 3. Again, we can assume the die is fair. If it wasn't, then we would be told that. Let me just stop this and start recording again. Let me stop the recording and restart.